My name is Samantha Llewellyn and I'm a research assistant here at Swansea University, and I'm currently working on a EU Horizon 2020 funded project called PATROLS, and that stands for Physiologically Anchored Tools for Nanomaterial Hazard Assessment. So the project incorporates 24 institutions across Europe and 8 different work packages, and each work package is responsible for a different sector. And so the project is looking at developing the next batch of 3D in vitro models for test systems, and the project that I'm specifically looking at is liver models. So I look at developing 3D liver models for nanomaterial hazard assessment. I work with HepG2 and HepaRG cell lines, and we are currently developing hanging drop spheroid models. And so we're looking to assess between HepG2 and HepaRG if we can get cell viability over a longer duration of time to allow for repeated E&M dose testing. To assess cell viability, we tend to use the Promega CellTiter-Glo 3D assay. It allows us to keep the spheroid as a whole, and with a lot of viability assays, they don't actually penetrate the core of the spheroid, which the necrotic core is a crucial part of or negative to the spheroid models. So allowing a kit that is specifically designed for 3D models allows us to assess the cell death in the centre of the spheroid as well as just the external surface. So in line with looking at cell viability, we've also been trying to establish between the HepG2 and HepaRG which cell line is most physiologically relevant to take forward. So we want to see which one has the best liver function output similar to that of primary hepatocytes and in vivo based models. So in order to establish this, we're looking at their liver function, so their AST, urea, albumin and CYP450 metabolic activity. So we decided to go for the CYP450 kits from Promega because they give us the option to do the cell-based or biochemical assays. So it allows us to harvest supernatant that can be used across multiple endpoints, as well as giving us the opportunity then to use the tissues for alternative assays. The flexibility also allows us, if we did want to look at the induction or a tissue-based level, we could also do that. So the ultimate goal would be to establish a liver model that is viable over a prolonged or extended period of time. So ideally one that can allow us to do long-term and repeated nanomaterial dose exposures, so over maybe 14 days and onwards. And then hopefully at the end of the project we'll be able to implement a model that's robust and high throughput, but yet has that advanced relevance similar to that in vivo. So in line with the NC3Rs, we're aiming to build a battery of models that can help reduce, refine and replace animal testing essentially.